Welcome to the Gen AI Daily Briefing for Saturday, August 22nd, 2026. The clearest theme in the last 48 hours is that the center of gravity is shifting again. We spent 2 years arguing about base models, then about post-training, then about reasoning. Now, a lot of the real action is in the layer around the model. Harnesses, routers, tool interfaces, and compute allocation policies. If you run AI systems in production, that's good news because those are levers enterprises can actually control. Start with Nvidia, which had a deceptively important research signal this week. The takeaway was simple. A well-tuned agent harness can make an average model look surprisingly competent and keep it from careening off the rails. That lines up with a new AR14 paper called Task Evolve, which focuses on harness optimization itself. The idea is that if you're iteratively rewriting prompts, tools, validators, and control logic, you shouldn't keep evaluating against a static full validation set every round. Instead, you adapt the validation tasks as the harness improves, cutting evaluation cost while preserving signal. The bigger point is architectural. For many agentic workloads, capability is no longer a property of the model alone. It's a property of the model plus scaffold plus evaluator. That should change how technical leaders budget effort. Another foundation model bake-off probably matters less than better state management, exception handling, and task-specific validation. Next up, there's a strong paper on adaptive reasoning at test time, titled Learning When to Think. It trains a model to choose among basically 3 modes before answering. No deliberation, short deliberation, or long deliberation. That sounds obvious, but most reasoning systems still burn a fixed budget or let users choose manually. The significance here is that the model learns a compute policy inside reinforcement learning rather than bolting on a separate controller. For anyone operating under latency and cost constraints, this is the right direction. Easy queries should not pay for chain-of-thought theater, and hard ones should be allowed to spend budget. Expect this idea to become standard in inference stacks. Route not just across models, but across reasoning depths within the same model. That connects directly to another useful AR14 piece, Pandora's AI model routing box. It formalizes something practitioners already know. Routing decisions are only worth it if the value estimation step doesn't cost too much. If you need a mini inference pass, retrieval, or a heavy classifier just to decide where to send the query, your supposed savings evaporate. The paper frames routing as a sequential decision problem with costly information acquisition, which is a fancy way of saying you should be selective about how much you spend deciding. This feels timely because product teams are turning routing into a default platform feature. Ramp, for example, just launched its own model router. I'd expect many enterprises to build internal routers next, but the mature design won't be always ask a smart meta model. It'll be layered heuristics, lightweight predictors, and only occasional expensive arbitration. On the model architecture side, one of the more interesting papers is Deadless 150M, a small language model designed for CPU inference from day one. Instead of starting with a transformer and trimming it down, the authors keep full attention in only a subset of blocks and replace the rest with short convolutions whose memory footprint doesn't keep growing with context length. That matters because KV cache growth is what makes many small models unexpectedly awkward on ordinary CPUs. This is a reminder that edge and on-device AI still have plenty of low-hanging fruit, not by copying frontier architectures at smaller scale, but by designing for the deployment target first. If your roadmap includes local copilots, offline assistants, or regulated environments where data cannot leave the device, CPU-native model design is worth watching closely. Worth flagging as well. MidTool, a paper on mid-training data synthesis for agentic tool use. The core idea is that general tool use is becoming its own capability family, separate from coding agents and separate from pure reasoning. MidTool builds synthetic supervision around real-world APIs, web data, PDFs, and code to strengthen that capability during mid-training, before downstream post-training or task fine-tuning. That makes strategic sense. Tool use is one of the few places where models can become measurably more useful without needing giant leaps in raw-world knowledge. If this line of work keeps paying off, we may see a divergence between models optimized for answering and models optimized for operating, where the latter are trained explicitly to plan calls, recover from tool errors, and keep state across external systems. There's also a healthy dose of skepticism in the research stream. A paper called Phantom Gains audits self-improvement claims and argues that a lot of reported gains disappear once you use proper controls. This is important because the industry is in danger of talking itself into recursive improvement methodology based on noisy eval deltas. The lesson for engineering leaders is boring but essential. If you're claiming your agent or self-training loop improved itself, your control pipeline needs to be nearly identical to the treatment pipeline. Otherwise, you're measuring benchmark drift, decode variance, or hidden contamination. On the market side, the most substantive data point is that enterprise buyers still don't look particularly loyal. New reporting suggests OpenAI is gaining ground on Anthropic with business users, but the real signal is volatility. Customers continue to switch as quality, pricing, and reliability move around. That means the model layer is still more contestable than many revenue narratives imply. For architects, this reinforces the obvious playbook: abstraction layers, fallback providers, and observability around quality per dollar. If your stack still assumes one vendor will remain best for 12 months, you're building on a premise the market keeps disproving. Infrastructure remains the other heavyweight story. Nvidia's partnership with data center developer Cloverleaf is another sign that the company is not content to just sell accelerators into demand. It wants influence over where and how capacity gets built. That makes sense. The bottleneck is no longer only chip supply. It's land, power, cooling, interconnect design, and time to energization. Nvidia participating upstream helps defend its position if cloud growth becomes constrained by physical infrastructure rather than silicon. There's also a weirder but notable adjacent item. Orbital data center startup StarCloud raised $250 million. I'd still put that in the speculative bucket, but the fact that it can raise at that scale tells you how seriously capital markets are taking long-duration compute scarcity and energy access. Finally, one underrated business signal. AI data startup Micro One reportedly reached a $500 million gross run rate amid the training boom. That is a big number, and it underlines something the market occasionally forgets. Even as synthetic data gets better, human-sourced data operations, labeling, validation, and domain-specific collection are still a major choke point. Training data has become its own infrastructure category. Not glamorous, but very monetizable. What to watch from here? First, whether adaptive reasoning and routing start to merge into a single inference controller. Second, whether harness optimization becomes a standard MLOps discipline instead of a bag of prompt hacks. And third, whether enterprise buyers keep multi-homing aggressively enough to compress model margins. If those three trends continue, the winners may be the vendors that orchestrate models and compute best, not necessarily the ones with the single strongest benchmark score. That's your briefing. We'll see you tomorrow.